All right, lesson 28. Going to talk to you about logarithms for the first time. In the background today, we have, hopefully you've been following the news, we got SpaceX. They launched, they connected to the International Space Station. That's pretty exciting. First time the United States has put astronauts up in space in, I think, like 9 years. I mean, we've had them ride with other countries up, but this is our first launch, I think, in 9 years. So it's pretty neat to watch if you haven't been following it. So let me show you what a logarithm is. It does involve the idea of inverse. We talked about inverse in our last lesson. We talked about how an inverse is basically a function that does the opposite of the original. Now, that's a very generic definition. I told you that before. But that's basically what it is. It just does the opposite. So when it comes to logarithms, logarithms are going to be the opposites of exponents. So let me just show you a couple quick things here. So if you have 2 raised to the third power, that's an exponent. 2 to the third, of course, means 2 times 2 times 2, which gives us 8. So when I give you an exponent, you raise it to a power and you get an answer. So you have your base of your exponent, you have the power of your exponent, and then you have the answer. All right? Logarithms are going to work a little differently because they're going to give you the base and the answer and ask for the power or the exponent. So they're going to be almost opposite of what an exponent will be. So let me just show you that real quick with a couple of examples. So if I wrote down our first logarithm here, so log, and when we write logarithms, they always have a base associated with them. So let me give this log a base of 7, and then I'm going to put 49 next to it. So there's a logarithm. And the way we say this is we say this is log base 7 of 49. So what does this mean? All right, well, this is different than an exponent because this time we are giving you the base, we are giving you the answer, and we're asking you for the exponent or the power. So that's how it's different than an exponent. So this is asking you 7 raised to what power gives you 49. So your answer you're going to get with logarithms is going to be the exponent. And by common sense, we can do this one. We all know that 7 to the second power is 49. If you didn't know that, you could always use your same basis thing that we talked about, where you take this 49 and change it to 7 squared, and then I can now make x equal to 2. But again, like I said, you can do this one with common sense. So log base 7 of 49, the answer is 2. All right? Because we're asking you 7 raised to what power gives you 49. Let's do another one. Here are 2 more logarithms. First one is log base 10 of 1,000. So again, just a reminder what logarithms mean. This is saying 10 raised to what power, I'm going to call it x, equals 1,000. Now you might be able to do that in your head as well. 10 to the what gives me 1,000. The answer is 3. If you don't see that, you can always figure out how to take 1,000 and rewrite it as 10 to the something, and it's 10 to the third. So you do get x equals 3 if you solve that. So 3 is the final answer to log base 10 of 1,000. Let's go over to this one. This is going to get a little bit more complicated. Log base 8 of 16 is saying 8 raised to what power gives me 16. To solve this one, you're going to have to probably do a little bit of work here by getting your bases the same, which we previously talked about. 8 can be written as 2 to the third, and that's still to the x power. 16 can be written as 2 to the fourth. Remember your rules here. When you have power raised to a power, you multiply. So that's going to be 2 to the 3x equals 2 to the fourth. Bases are the same. So 3x equals 4. Divide both sides by 3, and I get 4/3. So what that's telling me is that log base 8 of 16 is equal to 4/3. All right, a little bit more complicated there. Gonna do a couple more. Okay, 3 more, because these need some practice. First one, log base 10 of 1. That's telling us 10 raised to what power gives us 1. You should be able to know that just from the stuff we've done previously, that anytime you raise a number to the 0 power, the result is 1. So this is telling us the answer is going to be 0. X equals 0, or log base 10 of 1 is 0, because 10 to the 0 is 1. So there's that one. This one, log base 32 of 2, means 32 to the what power gives me 2. We're going to want to get the bases the same here. I already have a 2 over on this side. 32 can be written as 2 to the 5th power. And then exponent to exponent, you're going to multiply here, and that's going to give you a 2 to the 5x equals 2. Now 2 is really 2 to the 1st. Bases are the same, so 5x must equal 1. Divide both sides by 5, and I get x equals 1/5. So 1/5 is the solution to log base 32 of 2. Last one, and this is actually the trickiest one. There's a tricky one on your homework as well. This is going to involve a negative exponent. That's what makes it tricky. So we have log base 7 of 1 over 343. So just following our rules here, this is 7 to the what gives me 101 over 343. I got to try to get the bases the same. Now this is a fraction over here, so that must mean that this got to involve a negative exponent. So what we do is we try to figure out how we can write 1 over 343 as an exponent. All right, so if you first just think about 343, forget the 1 over part. Can I figure out 7 raised to something that gives me 343? Well, 7 times 7 is 49. 49 times 7 is 343. So that's what you're going to use. You're going to use the 3rd power. But this is 1 over 343. So instead of using the 3rd power, you're going to change it to 7 to the 1/3, 7 to the negative 3rd power. And the reason that works, let me just go off to the side here and remind you of that. 7 to the negative 1/3 is the same as 1 over 7 to the positive 3rd. And when you take 7 times 7 times 7, you do get 343. So this is 1 over 343. So that's why I can change 1 over 343 to 7 to the negative 3rd. Now my bases are the same, so I find out that x is equal to negative 3, which means log base 7 of 1 over 343 is negative 3. That's challenging, and there's one on the homework that's going to be like that as well. Bottom line, though, is just know that logarithms produce exponents as their answers. All right, so just going back to the beginning for 1 second. 3 to the 2nd power is 9. We know that because 3 squared is 9. But as a logarithm, we would be saying log base 9 of 3. Nope. Log base 3 of 9 gives us what? 3 raised to what power gives us 9? And the answer would be 2. So logarithms produce exponents as their answers. Instead of getting us an actual answer, they give us the exponent. So that's how logarithms